But the first assignment on section 1.1, there's a second one following this with other properties. So which sets of numbers does the number 3/4 belong to? Circle yes if it belongs to it, and no if it does not. Explain why it does or does not belong. So 3/4 is not a natural number. Why? Well, because it's a fraction, and natural numbers or fractions are not part of our natural number system because it is a fraction. Similarly, whole numbers are the same as natural numbers, except for whole numbers include the number 0. So I'm going to use the same reason. Integers, remember, are whole numbers including 0, and then they go to the negative counting numbers. So there's still not fractions in there. So it's not an integer for the same reason. Yes, it is a ratio because rational numbers can be written as fractions. And guess what this is, folks? A fraction. And 3/4 is a fraction. By the way, any integer, folks, you can write as a fraction by dividing it by 1. So that's a justification why any integer that you might see is also rational. If something is rational, it is not irrational. And then all of the numbers, same reason, because it can be written as a fraction. And irrational numbers can't be written as fractions. And then it is real. Rational numbers are real. All right. Now we're going to, forgot to erase this. Don't look. Let's explain. Yes, you can go back and rewind and copy that down, but I'm going to drag this slide right here and move it down here so we can reference back and forth quickly. So it says, name the set or sets to which each number belongs. Use the following abbreviations. Natural numbers are N, whole numbers are W, integers are I, rational numbers are RAT, irrational numbers are and real numbers are R. So 6, where does that fall? On this diagram that we made, I'd encourage you to find the smallest box. So notice over here, there are a bunch of boxes within boxes. I'd encourage you to find the smallest box, if it's on the rational side, that the number fits into. Like natural is the smallest box, and would 6 land on the natural boxes? Yeah, you bet it lands in the natural box. We'll get to 6 as we keep on counting. Well, whatever the smallest box is, you can include the other boxes that one is in. So the natural number box is within the whole number system, the integer system, and the rational system, and the real system as well. So, again, it was a natural number or a counting number, which makes it also a whole number and an integer and a rational number. And all of these that I'm seeing on this screen are going to be real numbers. So all of them will get at least this R with it. The number 0, what's the smallest box that it fits in? Well, it does not fit in the natural number system, but it does fit in the whole number system. So it fits in this circle, and then we can keep on working out. That means it's also an integer. You see 0 there, and it's also rational because it can be written as a fraction, 0 divided by 1. And it's also real. So whole number, integer, rational, real. Next is the number -2. So what's the smallest box that -2 fits in? It does not fit into the natural system. It does not fit into the whole numbers because they need to be 0 or positive. -2 fits into the integer system. Then it's also rational and it's also real. Integer, rational, real. Next, 16/15. That's a fraction. That means it's rational. And if it's rational, it's also real. So rational and real. Notice there aren't fractions on natural numbers, whole numbers, or integers. Pi, where's pi going to fall? Pi is not a rational number. So it doesn't even fit in this big box, this one up here. That means it has to be in this box. Sure enough, there's pi. So it is irrational, but it is still a real number. Oops, I wrote that in the wrong spot. Irrational and real. Square root of 27. Now, can you take the square root of 27 and get an integer or a natural number? No, you can't. The square root of 27, do that on your calculator, gets you a really messy, nasty, non-repeating or patterned decimal. So we can't write it as a fraction because there's so much mess with that decimal. It's irrational, but it's also real. -4 is going to be an integer. We'd get to -4 as we keep going with the integers. That's the smallest box it fits into. Should have arrows with these. Natural numbers go this way. Integers go to the whole numbers go to the right. Integers go to the left and the right, forever and ever with that pattern. So it is an integer. It's also rational, and it's also real. Last but not least, 14. That is a counting or natural number.
40?
For the time class ends?
No, your birthday.
Oh, not 40.
Oh, I think so. You said I did not identify with, so I thought maybe.
Oh, no, it wasn't the big one.
Okay.
It's just 37. So 14 is a counting number, which makes it natural. We're calling it natural. Whole number. Excuse me, by the way. It was my birthday yesterday. Integer. Rational and real.